Okay, good afternoon. Right, I'm Panos. I'm a PhD student here at UNB. And I also have a master's here at UNB. So I have one of these pins here for those who are planning on graduating. You're going to get one of these in the future. So, yeah. So I'm part of the IBM Center of Advanced Studies Atlantic. So it's one of these major research groups here in UNB. We actually have 13 posters today, if I remember correctly. So please go out afterwards and have a check and see what we're doing if you haven't done already. So our focus is not on cybersecurity. So I'm going to break a little bit the continuity of the event. We're actually working on performance. This is our main focus. And we're not working with IBM in Fredericton, but we're working with IBM in Ottawa. So there's an office there, a little bit different. Their focus is more on runtimes and clouds, and this is our work on. So besides performance, we're also working on dynamic memory management, parallelism, language features, and my topic has to do with cloud multi-tenancy. We have more than 30 researchers. And so far, we've produced 10 patents and disclosures. I'm actually going to discuss one of them today. And we also have, so far, 19 academic publications. So what I'm doing. My work focuses on multi-tenancy for the cloud. So there's a specific sub-project into the previous project that I discussed with. And our main focus is to try and optimize clouds on their performance, on their memory, and we're basically trying to put as many applications or websites, any way you want to think it, together, so that we're saving resources. That's the main idea. For this work, I'm going to discuss with you a new method which concerns reducing the startup and warm-up time while scaling. We're going to discuss about all of these different features. So the current status of this is that the prototype has been completed. We have some initial experiments, actually lots of initial experiments, that are complete and successful. And right now we're in the process of patenting this with IBM. So let's start a little bit about cloud computing. I need to give a little bit of an introduction since so far the focus has been a little bit different. So the cloud, what is the cloud? The idea here is that instead of you performing the computation to your local computer, you're offloading it to a centralized place. And it's a place where it actually has all the equipment that you need in order to perform your computation in the best possible way. A good analogy would be, for example, the service of electricity. You know, one way would have been for you to have your own generators, but you've outsourced this to big corporations which have the capacity to basically utilize hydroelectricity or nuclear power or other things that you would not be able to do on your own. And that allows you to become more efficient. The same idea happens with cloud computing. We're outsourcing computing resources, we're abstracting them. And of course, this can be, from the commercial point of view, this allows the pay-per-use paradigm, where you're only paying for the amount of computing power that you need. If you momentarily need a very large server, this is what you're going to get. And this is only how much you're going to pay. It doesn't make sense for you to go and buy a huge server if you're planning using it only for a couple of hours or something like that. And this is one of the benefits of the cloud. Other things are scalability, automatic updates, and security, because the people who are there, they're going to have a specialized team which will be responsible for security, to just bring a connection with the previous discussion that we're having. There are multiple different types of clouds. I'm going to discuss a little bit about the three main that are usually discussed. So at the lower level is the infrastructure as a service type of cloud. So at this level, you're basically sharing a large room, you're sharing computers, and you're also sharing power and heating bills, all of these things. So we're working at the lower possible level. If you want to interact with an IS cloud, you're going to get a virtual machine out of it. This is the idea, or a set of virtual machines. These are basically computers, or either real or virtual, it doesn't matter. Then, on the top level, the gray thing that I have over there, is the software as a service. And at this point, we're discussing about sharing the same application. But the difference is that we can customize the application for various clients. And although they might appear different, they're actually the same application. In between is the platform as a service cloud. And this is the cloud that I'm working with. This is the type of cloud that I'm working with. So these clouds are targeting developers and programmers. So for those of you who are technical people here, and you want to upload something on the internet, online, either that would be a web page or an app or whatever, we're targeting you. So what you do here is you're uploading your code, and then the PaaS cloud is providing you with virtual machines, databases, runtimes, load balancing if you have multiple instances, and other stuff. So a little bit more details about PaaS clouds, because as I said before, these are the ones that I'm working with. As a user, you're just uploading your code. For example, there are, if you have Eclipse, there's a plugin, and you simply drag and drop your code. It's that simple for most clouds. Then the PaaS cloud is responsible for finding hardware and software so that your application will run. The kind of hardware, of course, that you need is obviously the physical hardware or a virtual machine, depending on what kind of contract you have with them. Software has to do with the environment that is required for your application to run. For example, you might require some sort of language runtime. This is something that will be provided to you automatically. You don't have to do anything. You just upload your code. And also, you might need some sort of external services. A very usual thing that you might be needing is databases. So at this point, you just ensure that your application is able to talk with this kind of databases or web services or any other kind of cloud services, and the connection happens automatically. So basically, you drag and drop your application, and within 30 seconds or a minute, it's online. It's ready to use. You just go on the browser, you hit the URL, and your application is up and working. Some of these platforms are from IBM Bluemix, and there are some others from Heroku, Google App Engine, OpenShift. And in particular, I'm working with Cloud Foundry. Cloud Foundry is not a PaaS cloud itself. It's a software that enables clouds to work. So it's the actual software that that PaaS clouds run on. And it's open source. So what happens with your application once you have it online? In the beginning, you're not going to have that many clients. And therefore, if you're not going to have that many clients, you're not going to have that many requests. A request is basically whenever you type the address or you click a link and something loads on the screen of your computer. As time is passing by, you're going to get more and more requests. So at this point, you need to sort of start adjusting the size of your application to the available load. And there are two ways of doing that. The first is vertical scaling. And what you do in this case is you're simply beefing up your machine. You start with something that has 1 gigabyte of memory, you can go to 2 gigs, to 3 gigs, to 4 gigs. You have a single application, and you're making it larger and larger and larger. The other way to do this is horizontal scaling. In that case, you're simply adding more instances. So you start with 1 server, then you continue with 2, with 3, with 4, depending on how much load you have. Yeah.
Are you at some point getting to the stuff that you're working on?
Yeah, that is actually.
Because you're working
Okay.
on it, at this point you're reaching 10 minutes now.
Okay, all right. So I'm sorry for that. So the goal here is we're working on availability, and as you can see, when you're scaling, the availability might drop, and you might get this kind of page. The same happens with scaling out, and our work is basically this startup and warm-up time, which is by the time you're making the request to making something come up, to minimize it. And I'm just going to skip. So basically what we do is we have a method of capturing experience from the first application, and we're transferring this experience to subsequent applications, which allow them to start up and warm up faster. and I'm just showing here one example result. The blue one is ours, and as you can see, it's able to start something like 7 or 8 seconds faster. This is enabling better availability for the cloud because you're matching the load, and immediately you're getting back that much throughput that you need. So yeah, sorry, I ran a little bit more time than I needed. So in conclusion, I'm just saying that this is basically improving availability for clouds. And right now, we're at the point of trying to patent this. Actually, this has proceeded good so far. We're waiting to see how it will go from now on. All right, thank you.